Ketone bodies are three water-soluble molecules, acetoacetate, beta-hydroxybutyrate, and their spontaneous breakdown product acetone that are produced by the liver from fatty acids during periods of low food intake or fasting, carbohydrate restrictive diets, starvation, prolonged intense exercise, or in untreated or inadequately treated type 1 diabetes mellitus. These ketone bodies are readily picked up by the extra-hepatic tissues and converted into acetyl-CoA, which then enters the citric acid cycle and is oxidized in the mitochondria for energy. In the brain, ketone bodies are also used to make acetyl-CoA into long-chain fatty acids. The latter cannot be obtained from the blood because they cannot pass through the blood-brain barrier. Ketone bodies are produced by the liver under the circumstances listed above: fasting, starving, low-carbohydrate diets, prolonged exercise, and untreated type 1 diabetes mellitus, as a result of intense gluconeogenesis, which is the production of glucose from non-carbohydrate sources, not including fatty acids, so like proteins. They are therefore always released into the body by the liver together with newly produced glucose after the liver glycogen stores have been depleted. These glycogen stores are depleted after only 24 hours of fasting. So if you wanted to get into ketogenic or ketotic state or ketosis, the fastest way is going to be through a fast if you can tolerate it. Ketone bodies have a characteristic smell which can easily be detected in the breath of persons in ketosis and ketoacidosis. It is often described as fruity or like nail polish remover, which usually contains acetone or ethyl acetate. Fats stored in adipose tissue are released from the fat cells into the blood as free fatty acids and glycerol when insulin levels are low and glucagon and epinephrine levels in the blood are high. This occurs between meals during fasting, starvation, and strenuous exercise when blood glucose levels are likely to fall. Fatty acids are very high energy fuels and are taken up by all metabolizing cells which have mitochondria. This is because fatty acids can only be metabolized in the mitochondria. Red blood cells do not contain mitochondria and are therefore entirely dependent on glycolysis, the fermentation of glucose into lactic acid for their energy requirements. In all other tissues, the fatty acids that enter the metabolizing cells are combined with co-enzyme A to form acetyl-coenzyme A chains. These are transferred into the mitochondria of the cells, where they are broken down into acetyl-coenzyme A, CoA, units by a sequence of reactions known as beta-oxidation. Now we get into the uses of the various body parts. So uses in the heart, brain, and muscles, but not the liver. Ketone bodies can be used for energy. Ketone bodies are transported from the liver to other tissues where acetoacetate and beta-hydroxybutyrate can be reconverted to acetyl-CoA to produce energy via the citric acid cycle. Ketone bodies cannot be used by the liver for energy because the liver lacks the enzyme beta-keto-acetyl-coenzyme A transferase, also called thiopherase. Acetone in low concentrations is taken up by the liver and undergoes detoxification through the methyl-glyoxyl pathway, which ends with lactate. Acetone in high concentrations due to prolonged fasting or a ketogenic diet is absorbed by the cells other than those in the liver and enters a different pathway, though the pathway follows a different series of steps requiring ATP or adenosine triphosphate, can be turned into pyruvate. The heart preferentially utilizes fatty acids for energy under normal physiologic conditions. However, under ketotic conditions, the heart can effectively utilize ketone bodies for energy. The brain gets a portion of its energy from ketone bodies when glucose is less available. Example, fasting, strenuous exercise, low carbohydrate, ketogenic diet in neonates. In the event of low blood glucose, most other tissues have additional energy sources besides ketone bodies, such as fatty acids, but the brain likely has an obligatory requirement for some glucose. After the diet has been changed to lower blood glucose for 3 days, the brain gets 25% of its energy from ketone bodies. After about 4 days, this goes up to 70%. During the initial stages, the brain does not burn ketones since they are an important substrate for lipid synthesis in the brain. Furthermore, ketones produced from omega-3 fatty acids may reduce cognitive deterioration in old age.
Thank you for watching. Keep learning and keep it keto. So keto.com.